Hello and welcome to this live stream on solving algorithm problems. In this stream, I'll solve the second problem from the CSES problem set. This is a very simple problem. Let's go through the problem statement. You are given all numbers between 1, 2, and so on up to n except 1. Your task is to find the missing number. The input contains one line, and that is the integer n. So this n, that's the line of input. The second line contains n minus 1 numbers. Each number is distinct and between 1 and n inclusive. So there would be no duplicates. Each number that we will get in the second line would be distinct. The output should print the missing number. That's it. And then we have these constraints. So this is a fairly simple problem. The way we can solve this is by looking at what would happen if we were given all the numbers from 1 to n with nothing missing. In that case, the sum of all the numbers that we would get would be n times n plus 1 divided by 2. So that's the sum of all integers from 1 to n. But we will not be given all the numbers. We will be given n minus 1 numbers with one of these numbers missing. And we need to find that missing number. So let me denote this as S for now. I'm denoting this sum as S for now. What I'll do next is that as I receive these numbers one by one, as I read these numbers one by one, I'll begin subtracting them from this S. So the operation that I would do would look somewhat like this. Let me call the numbers that I'm receiving as K1, K1, K2, and so on. And I'm going to receive n minus 1 such numbers. So the result of this computation, that is this sum, which is denoted as S here, and then subtracting all the numbers I read from the input, would be the missing number that we are looking for. The reason is that this S is the sum of all numbers from 1 to n, and what I'm subtracting from it are also all the numbers from 1 to n except that missing number that we're looking for, except that x. So when we do this computation, we are just left with the number that we're looking for, which is x. So that's going to be the solution. Let me go ahead and code this thing. So we'll read the input in a variable n, and this would represent this n, which is specified as 5 in this example. Let me go ahead and read the first line of input. Now I'll compute the expected sum of all these numbers. So if we are given the number n, and if we add all the numbers from 1 to n, all the integers from 1 to n, the expected sum is going to be n times n plus 1 divided by 2. I have to be careful about the data type. I have to make sure that this int is large enough to store this sum, the maximum possible result we can get for this computation. So let me do a bit of calculation for that. What is the maximum possible value of n? It's 2 followed by 5 zeros. That is 200,000. So if n is 200,000, what can be n times n plus 1 by 2? It can be this big. And if you're using a 32-bit signed integer, that can have a maximum value of this, which is much smaller than what our maximum sum could be. I need a bigger data type to store this. I'll go for long because long is guaranteed to be at least 64 bits by the C++ standard. Okay, let me make sure that it is large enough. It certainly would be, but let me just confirm that. So this is the maximum possible integer that a 64-bit signed integer can contain. So it's large enough to store this number. Alright, now let me run a loop and read the next line of input, which will contain all the n-1 numbers except the missing number. I'm reading each number into this variable k, and then I'll subtract it from this sum. Okay, I'll call it s just to be consistent with the variables I used while explaining the solution in the beginning. In the end, what we'll be left with in this variable s would be the missing number that we want. Okay, so let me just check if this all looks good. I see a problem. There's a bit of a problem here. This is still going to be, so this is of type int and this is of type int. So this would still be an integer calculation, and the result that we would get would overflow the size of integer. So one way I can solve it is by denoting this n also as long. It's a simple way to fix that overflow problem. Yes, now I think we have a solution. Let me go ahead and test it. In the last stream, I had created a make file, which also requires some tests to be put in. So I will invoke the makefile target. I have a makefile to compile and run this, but it requires, one of the prerequisites for that makefile is to create some test cases. Let me do that. For now, I'll just feed the simple test case, which is check 5 2315. So this is part of my test setup. It supports a function called check. The first argument is the input, and the second argument is the expected output. Let me test this now. Oops, we are solving missing number, so let me test missing number. The test passes here, so it looks good. Let me go ahead and submit the solution to the CSES evaluation system. All the tests are passing, so that's it. That's it for this stream. That was a fairly simple problem. This is where I'll go ahead and end this stream. In the next stream, we'll pick up another problem from the CSES problem set. Thank you for watching. Bye. Bye and have a nice day.